Let's dive into how to write efficient regular expression patterns that won't slow down your code. Get ready to optimize your regular expressions for speed and efficiency. It is important to understand why regular expression performance is crucial. A poorly written regular expression can cause catastrophic backtracking, leading to exponential time complexity. Optimized patterns can prevent performance bottlenecks and improve the responsiveness of your application. One of the most significant performance pitfalls in regular expressions is catastrophic backtracking. Consider this problematic pattern. Open parenthesis a plus sign close parenthesis plus sign b. Nested quantifiers can cause exponential backtracking with non-matching strings. A better approach is to use a simpler quantifier, like this, a plus sign b. A simple quantifier eliminates backtracking while maintaining functionality. Anchors play a vital role in optimizing regular expression performance. Anchors prevent unnecessary scanning of the entire string. Consider this slower example. email@domain.com. Without anchors, the engine searches through the entire string, looking for matches. A faster approach is to use anchors like this. email@domain.com $. The engine immediately knows to check the start and end boundaries. Another way to improve performance is by using non-capturing groups. Non-capturing groups will help you avoid memory overhead when you don't need to capture groups. Using capturing groups such as open parenthesis https pipe ftp close parenthesis : open parenthesis www / close parenthesis example / creates memory overhead for each captured group. Instead, use non-capturing groups. Open parenthesis https pipe ftp close parenthesis : open parenthesis www close parenthesis example / These groups are for logic without memory allocation. Being specific with character classes helps to refine your pattern matching and boost performance. Narrow character classes reduce unnecessary matching attempts. A vague example is .star @.star. Dot matches any character, leading to excessive backtracking. A more specific pattern is open square bracket -z0-9 close square bracket plus sign at open square bracket -z0-9 close square bracket plus sign / open square bracket -z close square bracket open curly brace 2, close curly brace. These character classes limit matching to valid email characters. Atomic groups and possessive quantifiers prevent backtracking once a match is found. For atomic groups, you can use this pattern. Open parenthesis, greater than sign, a plus sign, close parenthesis b. Once matched, the group doesn't give up characters for backtracking. For possessive quantifiers, you can use this pattern. A plus sign b. This quantifier never gives back matched characters, eliminating backtracking. Here are some key takeaways. Use anchors to limit search scope. Be specific with character classes. Prevent backtracking with atomic groups. Use non-capturing groups when possible. Optimize regular expression patterns result in faster and more reliable applications. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.